distances here. Please don't assume them to be real. Obviously, this will be a real distance at the end. This point will be a real. So you'll assume here, assume this point to be wrist center. The center of the middle joint, this should be the wrist center.
I have a question. Why do we need the last revolute joint? Because it's on the same direction to the...
This is what happens. Okay, we'll get to this point. It's called a singular position. Singular position is when you have a manipulator, it depends upon how you look at it. In some positions, two joints will align in such a way that they'll generate motion in the same direction. But they're not always like that. For example, let's take this configuration, right? This is a wrist. What if this becomes 90? This joint and this joint will align, right? When this becomes 90 degrees, this point is right, when this goes up, like this. Okay? So in this case, what it has done is, you have this manipulator like this, but it's only at 90 degrees. So if I fold it like this, if this comes out of the board, I cannot draw it out of the board. If it comes out of the board, it will give you a revolution like this, which is not possible by this joint. Okay? So in this case, if you could draw 3D, then you would know, because if I fold it, the reason that this is drawn like this is because it will turn about this. So when it comes out, you'll get a rotation like this. Okay, so let's fix this DH table. I'm going to draw most of this in. So this is, let's go with setting up the base axis. Obviously this is Z0, let's call this as Y0, X0. Okay, so now, here you have Z0, this will be Z1, Z2, Z3, Z4, obviously Z5 is here, right, and Z6. So this, at this point what I'm going to do is I'm going to draw the wrist center here. So I'm going to say this is my wrist center. Because these three axes coincide here, this will be Z3 and Z5 in the same direction, and Z4 is like this. Okay, followed by Z6 over here. Okay, now fill up the X. Okay, this is the wrist center. You have Z3, Z5 going like this, Z4 going up, and that is Z6. What I've done is I've combined the three frames here. So this will be all 6. All right? So you will fix this. So these two are parallel. You can take any way you like. So I'll take this as X1, X2, X3, right? When it comes to X4, it will be here. Okay, X4 has to be parallel to these two, X5 has to be parallel to these two, and this will be X6.
Professor, Z5 should be before the end effector or?
Which one?
Z5 should be after the joint or before the joint?
These three joints are at the same point. It does not matter if I write it here or if I write it here, because all three of them are like here, right at the wrist center.
Okay, because we have two Z's for this joint, which is...
You have two Z's?
We have Z4 and Z5 for the same joint. We should put the Z5 after the joint.
After the, yeah.
Okay, the reason I draw it here is because all the three joints fall at the wrist center. It does not matter if I draw it here or if I draw it here. It's exactly at the same point, right? Because what you're trying to say is I can have 3 rotations about the same point, which is the wrist center, okay? So this joint, as I mentioned, these distances are 0. The reason we draw them separately is for you to have space to understand what they are, right? If I draw all of them like this, you cannot measure the angles because you don't know which one follows after which one, okay? So you space them out like this, okay? But actually all the Z's are coming out of the same point, okay? Which is the wrist center, all right? The only reason we do this so that you can measure one angle with respect to the other. All right, so I'm going to have you fill this out. Let's stop at this point, please. Obviously, this is not a unique choice of x. You can pick x in any other direction. For example, these two are collinear. I can pick x like this also. These two are like this. I can pick x within the board also. So it's up to you. The choice of x is not unique. You can come up with a different choice of x. But please finish this table and then we'll do one more example with a wrist. Okay? And one more thing that I want to mention here is when we do the table here, when we do the dx table here, or when we do the transformation, you will have, in this case, because every row is an A matrix, you'll have T06. Okay? So this will give you a forward kinematics. This will be R06, D01. 4 by 4. Okay? So from here, from R06, you can either get your Euler angles or your RP1. Okay? Is that clear? So you can either get Euler or RP1 angles. One more thing is, we mentioned that the first 3 joints are responsible for theta. I'm sorry, for the position. So this will give you XYZ, okay? You should get XYZ from here. This is a function of, all right? And we should be able to undo this from here. So from here, we should be able to get theta 4, theta 5, theta 6. So we'll talk about how to do this when we go to inverse kinematics, but when you multiply this, you'll get, I'm not going to give you examples where you have to multiply 6 A6 matrices because it'll be too long. The only multiplication you'll have is from A1, A2 for 3 degrees of freedom. Okay? All right? So,
Is this 4 by 4 or 6 by 6?
4 by 4. Why would you have 6 by 6? Why would you? All A matrices are 4 by 4, right? So if you multiply 4 by 4, you'll get a 4 by 4. Why will you get 6 by 6? Right? 4 by 4 times 4 by 4 is 4 by 4. Okay? So from here you'll get XYZ, which is D, as a function of theta 1 to theta 6. So XYZ will get the function as this. Even your R matrix will be like that. But we will decouple this when we go to decoupling. So at this point, understand that your forward kinematics when you do for this manipulator will have 6 thetas. Okay? Alright, please finish this table. I'll do it when we meet again, but I would like you to have some practice so that we can all come to the same solution. And we'll do some other examples with the spherical wrist.